Now the next problem which we have is, it's a bit tricky and a very important problem, considering we would learn two different expansions in this single question. We want to find the limit of 1 plus x power 1 by x minus e plus ex by 2 divided by x square as the x tends to 0. Now we see that this is neither a 0 by 0 format or an infinity upon infinity format or 1 power infinity format. So we cannot use simple approaches in this type of problem. Instead, what we do is we try to convert this confusing term into a bit simpler term. What we can do is we can write this as y equals 1 plus x power 1 by x. Now ln y, on taking log both sides, we get ln y equals ln of 1 plus x by x. Now there is a very important and a very basic expansion for this ln of 1 plus x, which I would request you students to remember because it is highly useful in some of the limit problems. This ln of 1 plus x can be written as x minus x square by 2 plus x cube by 3 minus x power 4 by 4 up till infinity. All the even terms have negative sign with it, and all the cubic or all the odd terms or all the odd parts of x have a positive sign with them. So this is the expansion of ln 1 plus x. So we put this expansion over here to get ln y equals, and on dividing this by x we get ln y equals 1 minus x by 2 plus x square by 3 minus x power 3 by 4 up till infinity. This is the value of ln y. So y will be equal to e power 1 minus x by 2 plus x square by 3. Now we need not take the rest of the powers, since the highest power of x in the denominator is 2. So the rest of the powers are useless for us. So we just take y equals e into 1 minus x by 2 plus x square by 3. Now what we do is we again try to simplify this term. We write it as e into e power minus x by 2 minus x square by 3. Now here a very important and the second expansion involved, which is the expansion of e power x, which is equal to 1 plus x upon 1 factorial plus x square by 2 factorial plus x cube by 3 factorial up till infinity. Here we have e power minus x type of term. So it is very easy. We put x equals minus x over here to get 1 minus x upon 1 factorial plus x square by 2 factorial minus x power 3 by 3 factorial and so on. So now what we do is, this is also very important expansion of e power x, which I would request you students to remember because it can be highly useful in some of the ln and e exponential limit problems. So now what we write this as, we put the expansion or the value of the expansion over here to get e into 1 minus x by 2 minus x square by 3 upon 1 factorial plus 1 upon 2 factorial into x by 2 minus x square by 3 whole square plus 1 upon 3 factorial x by 2 minus x square by 3 whole cube and so on. Now we see in the denominator we have x square term, and we are not getting x square term from any factor or any term after this term. So these all terms are useless for us, we don't require them. So we get this thing divided by, not divided by x square, this is the value of y, which is e 1 minus, we collect the coefficient of x and x square to get 1 minus x by 2 plus x square. Now here it is 1 by 3, here we will get 1 by 4 into 1 by 2, which is equal to 1 by 8. So we get x square into 1 by 3 plus 1 by 8, which is 11 by 24, and rest all are cubic power 4 terms which are useless for us. So we get y value as y equals e into 1 minus x by 2 plus x square into 11 by 24. So we put this value in our original problem to get, this is y minus e plus x by 2. We take these two terms on the left hand side to get y minus e plus ex by 2 as x square into 11 by 24. So put this value over here in the numerator to get limit x tending to 0, x square into 11 by 24 divided by x square. X square gets cancelled out and we get the final answer as 11 by 24. So in this problem, we saw two different expansions which were highly useful. The first expansion was ln of 1 plus x, which is x minus x cube by 3 plus x power 5 by 5 and so on up till infinity. And the second expansion was of e power x, which is 1 plus x upon 1 factorial plus x square upon 2 factorial plus x power 3 upon 3 factorial and so on up till infinity. These two expansions are highly useful because they help to ease out the problem in a very simpler way. So we would use these expansions in the further questions also. So I would request all of you to try to remember these expansions. They are not difficult. They are a bit confusing because there are a lot of expansions of sin x, cos x, tan x, e power x, ln of 1 plus x. They are a bit confusing because they are all similar type of expansions, but they are not difficult. So if possible, I would request all of you to remember these expansions. And the final answer of this problem is 11 by 24.